Hello everybody, my name is Chris Ward and I'm one of the product managers for the control product business, and in this example I intend to demonstrate one of the functions in the SIMOCODE station, and I want to focus around the power monitoring function, which is integrated into the SIMOCODE Pro V unit, providing that you use a CT and a VT module. So if you haven't got a base project in, please refer back to one of my previous videos which would demonstrate how to be able to do that, because we're purely going to be focusing on the actual function itself. So why would you use the power monitoring function? Well, if you've experienced premature failures of key equipment with your facility, so like a power monitoring system can act as your crystal ball to clarify if your motors, pumps, whatever device it may be, are susceptible to premature failures. So if they fail earlier than predicted, you can investigate the possible causes. And normally things like harmonics can cause that transients that can cause microjogging and motor vibrations in motor bearings, and other things like transients that can cause cable insulations to heat and wear, resulting in short circuits. So another reason why you might use it is if you've had nuisance tripping or unexplained resetting of controlling devices. So if you've got a programmable logic controller or a DCS system that automatically resets or cycles the power. Do you have a circuit breaker that trips for no apparent reason? Nuisance tripping can negatively affect your facility, so ruin the quality of a manufactured product or even cause an emergency power supply system to come online during a non-emergency. So undervoltage is one of the biggest culprits behind nuisance tripping. So if you have had voltage fall below the IEE standards, it'll often cause your equipment's power supply to reset. So another reason as well is if you want to keep an eye on the allocated costs with complicated electric rate schedules. So in facilities with electric rate structures that require on-peak and off-peak time of use, peak demand charges, for example power factor penalties, or even real-time pricing, most automation solutions don't have the capability to handle complex cost allocation calculations. So a power monitoring solution can, for example, in an industrial facility's peak demand charges might be larger than the energy charge. So software that detects that when the plant is at its peak demand and then maps each cost centre's contribution makes the allocation of energy costs more accurate. Now SIMOCODE doesn't do that, but it can monitor the power and it can feed it to a piece of software that actually does that. So another reason why you might want to use active power monitoring would also be as well is that you can use it for pump flow detection. For example, if the flow inside a pipe is decreasing, the active power would also decrease, which means that the pump could effectively run dry. So the idea is you can set a threshold which would indicate that the pumps run dry and it could effectively trip the motor out. So the idea is you're stopping the motor and the pump from running dry and preventing damage to the pump and the motor. The older solution of being able to do that would have been by using a PLC and a PI instrumentation device. So a PLC and a PI instrumentation device would cost substantially more than a SIMOCODE control station. So I'll jump into the configuration now and show you how to use that. So if you go into the control device, parameters, and then from in here, machine monitoring, and as you can see down here we have active power monitoring. So if we just bring that sub menu to a close, we'll get a better view of the active power that we can see. So as you can see, a bit similar to the other functions, we've got an upper limit and a lower limit, and also there's a trip level here, a response to the trip level. So how do we want it to react to that trip level? I mean, in the majority of circumstances that higher threshold would be trip, again to have so that you don't have any nuisance tripping. You might want a time delay, And then similar to the other devices and the other functions, you also have a warning level. You can decide how we react to that. Typically for that you wouldn't have a trip, you'd have a warn signal which would flag to an engineer that the power is approaching a level which might want to be looked at by an engineer before it reaches this trip level and causes any unexpected downtime. Similarly with power, on the lower threshold you have the exact same functionality, so you have a trip level, you decide how it reacts. So again, we typically select trip for that, and then you have a time delay on that, and then there's also a warning level and a response to that warning level. So again, we'd either want it to signal or warn. We could have that to warn the engineer on a HMI to signify that somebody might need to come out and have a look at how that motor's operating to ensure that there's no unexpected downtimes. And once you've derived what you want your trip level to be and your warning trip level to be for both the upper and the lower limits, you can then download that into the SIMOCODE station. Once you've downloaded that into the SIMOCODE station, you'll then have the functionality of the active power monitoring, which will be up and running. As you can see on the trip levels, you do have quite a large scale to pick from in terms of setting the rating for those trip levels, whether that be on the trip level or whether that's on the warning level. But it's down to you to pick that out from your pump application curve. So you can find out what the trip level might be and the warning level might be based off the pump curves for both the upper and the lower limits. So I hope you found the video useful, and please stay tuned for more videos to come on the applications for SIMOCODE and also for the soft starter range. Thank you.